this video I'm going to be talking about 1.8. 1.8 is all about composition of functions. This can be used for businesses if they want to maximize production or cost, or not maximize cost, but maximize what they're making, their income, their revenue. So just different types of things that they use. For instance, if they have f plus g of x, this is the same thing as f of x plus g of x. F minus g of x, f of x minus g of x. Okay, these are two different functions. F times g, so f of x times g of x. F divided by g, f of x divided by g of x. This is the only one new that you probably will kind of be a little bit weary of. This is f of g of x, which can be written out f of g of x. Basically, when you work these things, you're going to work from the inside to the outside. Treat it as if it's one giant parentheses. When you do parentheses, you have to work from the inside and then work on everything on the outside. Well, we have this parentheses right there keeping the g of x on the inside. So we need to figure out what g of x is first, or whatever is inside, and then we'll work with f of x. Now let's look at some examples. Consider these first two. I have the function f of x equals x squared plus 4 and g of x equals 2x minus 7. In this one I have f plus g of x. Don't forget that all this is f of x plus g of x. So what I can do is I can have the function f of x, which is x squared plus 4, so I have x squared plus 4 plus whatever g of x is. Well, g of x is 2x minus 7, so plus 2x minus 7. Nothing really to distribute, so I can just rewrite my function. So I have x squared plus 2x. 4 minus 7 is negative 3. That's as far as I can go. There's nothing to plug in. I'm not trying to factor or solve or do anything like that. In part B, we have f minus g of x. Again, don't forget that this is just f of x minus g of x. If it helps you out, you can just rewrite it, like I did on top of this. So f of x is still x squared plus 4. So x squared plus 4. Now minus g of x, so I have to minus the whole function. So minus 2x minus 7. Because these parentheses are important, because now I see that I need to distribute this negative to both of my parts on the inside. So x squared plus 4 minus 2x minus to the 7 term, so that'll make plus 7. So now I just combine like terms again, so I'll have x squared minus 2x plus 11. Now I'm going to look at the multiplication and division of these things. So fg of x, this is f of x times g of x. So f of x is x squared plus 4. G of x is 2x minus 7. So I'm going to multiply. This is the FOILing, this is the distribution. So distribute your x squared to both terms, your 4 to both terms, and see what it comes out to be. So x squared times 2x is 2x cubed. X squared and 7 make negative 7x squared. 4 and 2x make plus 8x. And 4 and minus 7 is minus 28. No terms to combine, so that's actually just our answer right there. Over on the other side, f divided by g, this is f of x divided by g of x. So I can literally just take my function f of x, x squared plus 4, divided by g of x. Well, g of x is 2x minus 7. No terms combined, nothing to reduce. That's as far as I can go. Now I'm going to get into the more challenging stuff to understand, and that's okay. So f of g, don't forget this is just f of g of x. Whatever comes first in this pair must come first in this pair. So I don't really know any number or anything for g of x, but I do know g of x is 2x minus 7. So I can say this is f of 2x minus 7. Well, now this says go to f, plug in 2x minus 7 where I see an x. X is right here. So all I need to do then is put in, oh no, 2x minus 7 for that x. Oops. So 2x minus 7. It is squared, so I'm going to square it here. Plus 4 is on the outside, so plus 4. And then it's just a matter of reducing this. But don't forget that 2x minus 7 squared is the same thing as 2x minus 7 times 2x minus 7. It is not 4 squared plus 49. Okay, you'll be missing your middle term if you do that. So this will come out as 4x squared minus 28x plus 49 plus 4. And then just combine like terms. So 4x squared minus 28x plus 53. Okay. Likewise, notice what comes first must come first when you rewrite this thing. So this is g of f of x. So go to f, plug in x, go to f, plug in x, so it's already done. So this is g of x squared plus 4. Now it says go to g, plug in x squared plus 4. So I'm going to go to g. This is my g function. I'm going to plug in x squared plus 4 where I see my x. So this is the same thing as 2 times x squared plus 4 minus 7. And then it's just a matter of distributing the 2. So 2x squared plus 8 minus 7, which is 2x squared plus 1. And there it is. In some examples, you can actually solve for a number in the end. When you're given a 1 or a 2 or any number instead of an x, we can actually plug these in. So this would be the same thing as f of 1 times g of 1. So all you're going to do is find the value of f of 1. So go to f and plug in 1. 3 minus 2 times 1 is 1. Go to g, plug in 1. 4 minus 1 half is 3.5. So 1 times 3.5 is 3.5. So I would actually get a value in the end of f times g of 1, rather than having the x like we were seeing before where we would come out with some other sort of equation. Okay, same can be done with g of f. Just notice this is g of f of 2. So I'm going to go to f of 2 first, work inside to outside, don't forget. So go to f, plug in 2. Go to f, plug in 2. If there's a 2 here, 3 minus 2 times 2 is 3 minus 4, which is negative 1. So now I can go to g and plug in negative 1. So if I go to g, plug in negative 1, 4 minus negative 1 divided by 2 is 4 plus 1 half, which would end up being 4.5. And that would be it. Hopefully this helped you guys out with composition of functions. Keep practicing, keep working on it. Make sure you guys ask lots of good questions. Thank you again for watching, and I'll see you all in class.